Hello everyone, welcome once again to my channel, and in this video I'm going to talk about pods. So before going into the depth of it, it is important to know about kubectl or kubectl. So this is the command line tool that helps you run different various Kubernetes commands on a cluster. So what you get to do with kubectl is you deploy your applications, you inspect them, you manage all your cluster resources, and also in addition to that you can view the logs of different workloads that you are deploying. So it is necessary to know more about kubectl and the commands that are required in order to manage your resources well. So kubectl is the client-side tool that gets to interact directly with the kube API server and handles whatever you are requesting, or what different kinds of workloads that you are running underneath. Moving ahead, what is pod? So it's the smallest deployable unit in Kubernetes. So a single pod comprises of multiple or one containers, the shared storage, it could be the node on which it is running, the pod is running, the network resources, and certain specifications. So specifications in the sense the amount of CPU it requires, the amount of memory it requires, all those informations. Okay, they are all encapsulated together to form a pod. Before going into the pod, an important concept about namespace is very much critical. So it's the logical grouping of the workloads or resources that you are creating in a cluster. So a single cluster can have multiple such namespaces. By default, Kubernetes has a default namespace and another separate namespace where Kubernetes components do run. So in this namespace, you can create workloads that are of unique names. So no two workloads, no two resources or workloads can share the same name under a namespace. However, two different namespaces can have identical names of workloads. Say in namespace ns1, you can run a pod, say my pod, and in namespace 2, you can also run a pod named my pod. But no two pods should have the same name in a single namespace. Moving ahead, how these pods or the applications that you are going to run, or the workloads, they get actually deployed and they are controlled. So earlier, replication controller is one of the controller that used to do that activity for you. So you have to specify that I require n number of pods, and replication controller is that constructs in the kube controller section that used to ensure that n number of pods are always up and running. However, ReplicaSet does the same. In fact, it is the newer generation of replication controller. It helps you with the interaction of ensuring that whatever the number of pods that you have specified remains up and running all the time. But what it also does is it ensures it is controlled basically with the help of a deployment. So deployment is nothing but an upper level constructs that works on ReplicaSet, and ReplicaSet ensures that the pods keep up and running. So how it works? So for example, if one of the pod goes unhealthy and it dies, ReplicaSet ensures that specific pod is replaced with a new one, so that the number of pods that you specified are always up and running for you. Now, coming to the demonstration part, how you get to create a Kubernetes pod. So this is what Killer Code console looks like, and here it kind of gives you a playground for playing around with the Kubernetes. So the first and foremost thing to know about is kubectl. So this is the kubectl. If you talk about, so this is the version that that is supported currently, and in this specific cluster or console. So you can check the documentation, what is the latest version of it, and what's the kubeadm or the cluster Kubernetes API that you are specifically using in your cluster. What are the different versions that are available? And there is a complete documentation that specifies the version compatibility chart among various components. Cool. So what is the command kubectl, so the command to run, so there are two types of command. So one, you get to do it directly through your console using a single kubectl command you can create. The other thing is, I will show you two ways. One is the imperative way and other is the declarative way. So let's try to create one pod which is through the imperative way. So kubectl run, this creates a pod, okay, and followed by the name you have to give, say my pod. So you need to specify what image you want specifically, right? So if I want to run an nginx, okay, and if I go ahead and execute it, so it creates a pod slash my pod, the pod name it creates. So this specific client tool, it interacts with the kube API server which is running on this cluster, and the cluster, it then provisions the underneath resources, whatever, and whatever image you have talked about, so it creates. So let's try to track how it got created. So let's try to get hold of the kubectl get pods. This is what gives you the what are the list of pods that are running in the current namespace. So this is what it is running, right? My pod. Now in case you want to see all the pods that are running in the cluster, so as you can see, a namespace, in the default namespace, my pod is running, right? While there are other namespaces which is kube systems, you can see there are other components that are running which are specifics to the cluster, and you get to, by default, this is what it is picking up the current namespace, but there are ways you can change in case you want to specify to work by default on a different namespace. Okay, now what we were thinking of, we wanted to know more about our pod over here, which is my pod that we created. Kubectl get pod, then followed by -o, that means we are specifying the YML format in our output. So as you can see on the screen, very important parts, you will find how it looks like. So first part is an API version, which is v1. Then comes the kind. What kind of workload is this? So it's a pod. And then there are a lot of metadata related informations. We're not going into the depth of that, but the most critical part within the metadata is the labels. So labels is something that gives you an identifier in addition to what we have for pod name, other than the name. So labels is a key value pair that you associate it with one of the resource so that it can be filtered, or it can be fetched from that specific key values set. We'll come to that topic while discussing about service. Then the another aspect you see here is definitely the name is there, as well as the namespace. So which namespace do the pod belong to? Now the most critical part of the pod is this thing. So as I said, what is pod? So it's a group of containers. So it could be multiple containers that are associated, or it could be and as well as volumes and all those information. Okay, so container, what container I'm using? I'm using the name is mypod, and the container image I'm using is nginx. Okay, and there is a volume associated, which is a volume mount, which is designated with the help of a volume mount, and it is being specified by the name, which is kube API access this. So if you find and go below, so this volume mount actually denotes to a physical volume that is available on the node where the pod is running. That means the server where the pod is running, and it designates a physical location. Okay, so there are many other fields here in this output. Let us ignore them for now, but later on we'll get to know gradually what those things are. Now, what are the events that has taken place? So if you get a hold of kubectl describe pod my pod, so get pod means you want to get the information about the pod. Describe pod means we are trying to describe what the pod is, container is made of, and what all events that took place. So if I click on kubectl describe pod command, you will find more details. So what's the name, what's the namespace, what are the labels associated. So you see key and value, at what time it started, and the containers. So if I scroll down below here, you will find how the events went through. What were the events that happened? So it's C. It is assigned to a node. The node over here is the node name, which is control plane node. So if you want to know how many nodes are available associated with this cluster, kubectl get nodes. So currently there is only one node, which is the control plane node here. There are instances where you will find multiple nodes are connected. So node 0, node 1, all those nodes you will find in the killer code or any kind of CLI core playground that you are using for getting a proper hands-on. So if I describe it again, yes, this is the thing. So conditions, you will find the what is the status of different conditions, whether it is initialized, whether it is ready, or the container is ready, or the pod is scheduled. So these are various parameters through which the kube scheduler would actually try to look into the definition of the pod, and it will try to schedule it to a node, and the health of the node, and the basically the node where your workload is deployed. So each node, as I mentioned, would have a pilot, right? Would have a captain of the ship, which is kubelet. So kubelet takes care of that, uh, so that the node is kept healthy. Now, so this is one way we learned about, right, in order to create a pod. So let's try to see, that's an imperative way. We will try to create a declarative way where we will specify, we'll create a YML. So kubectl run my pod hyphen hyphen image equal to nginx. Now what you need to do, so how first let's try to delete this pod, the existing pod. So it's easy, kubectl delete pod followed by my pod. So you will find the pod got deleted. Okay, now if you try to get hold of all the pods that are running in your cluster, none in the default namespace. Now we'll try to again recreate the same pod. Okay, but dry hyphen run equal to client and hyphen o YML, and I will try to capture in pod.yml file. So let's try to see what does pod.yml include. So it has a very small information as of now. So difference between by getting the get command and capturing it in YML format once the pod is running, and using this command to capture the pod information first before it's creating, you will find a lot of differences. But ultimately the structure remains the same. So it uses the API version v1 and all these details. The critical part over here is labels run my pod and spec containers and the container details. Okay. Next thing, in order to make it effective, so we have a pod.yml, right? So what we have to do, kubectl apply -f pod.yml. Now your pod is created. Now I will try to find out what happened with the pod. Now it got created, and if I simply fetch all the pods, you will find that 15 seconds ago it's the edge of the pod for which it is running, and this pod is healthy now. But what happens if this pod gets killed? Okay, so we need to create some kind of a resource that would monitor, a controller that would monitor, okay, this pod remains active, or n number of pods remains active, right? And that has to be done with the help of a deployment. So underneath the deployment resource, it uses the ReplicaSet, which is the modern day replication controller. Okay, so we'll try to create that, but let's clear off this mess from here. This pod, my pod, it's done. Now we want to know what we need to know. We want to know that how a deployment is created. So kubectl create if you want to know more about how it works, create help help, sorry. You will find more information like what you want to create, what are the supported commands that are available. So we are looking for creating a deployment, right? So we will go kubectl create a deployment and say dep1 image. We specify what the image is, which is nginx, and uh, replicas. Replicas is, say for example, 10, and then dry run. I will explain what I'm doing here. Dry run, sorry, -o yml. I will capture is in dep1.yml. Okay. Now let's try to see what dep1.yml is all about. So this is a deployment. So deployments are designated with a different API version, which is apps v1, unlike the one that we are using, which was v1 in case of a lambda, in case of a pod. So the kind here is deployment, and the labels that we are using is app dep1. So now you will understand what's the importance. So in specification, we are talking about what my container will be. So whatever you are seeing inside the specification spec, so this is about the container, and whatever things you are observing within with this spec is basically about the deployment. So deployment is a wrapper. But how this deployment object will understand, okay, I am being designated to work on these containers or these pods. So this is what is achieved with the help of selector over here. So in containers, you see which is saying the labels is app equal to dep1. So the deployment object has to specify, okay, these are going to my pods, right, which I'm going to manage. How will it identify? So it will identify with the help of the selector match levels key value pair. So selector match levels, and it specified that app equal to dep1. So that means whichever the pods have app equal to dep1, they would be coming under the scrutiny of this deployment object. Okay, let's quickly go and create it. kubectl apply -f and followed by this. So it got created, right? So let's try to see kubectl get -all. If I press this, okay, sorry. So kubectl get all, if I do, so in the default namespace it will try to check what kind of what kind of things we are actually asking for. So first is the replica set, if you see. So it created a replica set, right? So it always takes care of that. That desired is 10, current is 10, and 10 are ready, which is being again controlled by this deployment. And underneath again, so you see 10 pods are created. Okay. So if I specify kubectl get pods, so I will see 10 pods are running. Say for example, I want to now delete one of the pod deliberately. So I select one of them and delete it. Okay, this pod is vanished. Now you see over here the 10 remains intact. So all were running earlier from here to here, but now what happened is, since I have removed one of them, and I have a deployment workload running over here which is taking care of the number of pods to be intact, it has actually spinned off another container for me. So in this way it ensures that the number of pods we want in the cluster for a specific application remains intact. So a similar approach you will be learning in the next sessions, like I will check with the feasibility of it. So we have another controller called daemon set. Okay, so daemon sets means if you want to keep a specific type of pods up and running in n number of nodes in the cluster, so the daemon sets is that controller component that ensures that those n number of pods are all distributed, so at least one of those pods are running in one of the nodes, at least one nodes. So that kind of one-to-one mapping it maintains. So this is finally, before going, I will show you the command get deployments or deploy is something that we use to check that. So this is the deployment that got created. So now if we want to delete this deployment, how we do that? Deployment dep1. So once we delete it, if we now check the pods, so all are getting, most of them are getting terminated, and finally you will find no pods remaining in the namespace. So what did we learn about in this session today? So we understood what a pod is, how pod works, and what how pods are controlled, how pods are created, they are deleted in two ways. We talked about declarative way, and another one is the imperative way, that is passing parameters through CLI commands, while the declarative is the YML approach. You save the YML, you use kubectl apply or kubectl delete commands. And then we talked about deployment, replica sets, and how it ensures that the number of pods that it is running are intact in your cluster. Okay, so in this way, like we'll be learning gradually more about other components and how you develop an application and deploy and keep it maintaining in a cluster. Next video we'll talk about services. Till then, if you have any questions, drop a note on LinkedIn or over my videos, so that if you have any queries, I will try my best to address them. So for now, ciao, have a great day, bye, take care, cheers.